Hello student, I am Arnab Das. Today we discuss about the representation of convolution code. Last few classes already we discussed about various way or various process by which the convolution code how it can be encoded on there. That is the process we discussed the last few classes. Now today we discuss about the representation of convolution code. For representation of this convolution code, there are three kind of way it can be represented. First one is the state diagram, second one is the tree diagram, and third one is the trellis diagram. These three diagram individually have most effective one for representing the convolution code. Why it is required? Because if you know the state diagram, from the state diagram you can easily able to identify what will be the encoded data for representing the convolution code. So this is not required the ultimate step-by-step process to get the encoded convolution code. From the diagram easily you can able to identify what will be the encoded data will be on there. So first of all, we talk about the state diagram. For the state diagram, initially we just consider the state table for the 212 code. That is for the convolution code, which one we are considering. That 2 which is defined the value for the small n, which is represent the how many number of output line is there. In this case, the output line is 2, and due to this 2 their output can be 00, can be 10, can be 11, can be 01, whatever, but it will be two digit form. Now here 1 is represent the number of input line, and which is defined the k is the number of input line. That means single bit data would be used as the input for this convolution code diagram. And here the input can be as a single bit digit, it can be 0 or it can be 1 on there. And the last one 2, which is indicate the number of memory unit, and which is defined by the small m. And the memory unit can be stored as a data of 2 digit. Due to the reason of this is memory unit is the 2 on there, so it can be stored 00, it can be stored 01, 10, 11, whatever. And when the memory unit triggered, that time the value can be changed on there. Initial value can be defined as a present state value. This is ps is stand for that present state. And after the triggering, its value can be changed or remain the same value, though this after the triggering the value will be defined as a ns, that is the next state value. So again I just repeat that ps is defined for the memory unit the present state value, and is defined after trigger what will become next for the next state value for the memory unit. And this can value will be 001011. That means for the two memory unit their two data can be stored on there. That means 2 bit will be stored at the previous present state or the next state position. So next we are look for the condition. Let here for the present state value initially is as a value of 00. So 00 here s0 is defined as a written form. Is here the 0 as a suffix for the s is defined the decimal value for this 00. If you consider for the 01 for this binary number, the decimal value will be the 1. So here suffix is written for the s as a 1. For the 10 it is the 2. So it will be written as a s suffix of 2. If it was as 11, that time the s will be suffix as a 3 on there. So initially we just considered there the state value for the present state value is the 00 on there. If the value is the 00, that time input will be as a single bit data. It can be as the apply of input 0 or maybe the 1. And due to the input of this value as a initially we just consider the value is apply as a 0, that time that due to the circuit diagram for this 212 code, let it is maintaining the same value for the next state, that is the 00, and the output is as a value of 00. And when for this same present state value, that is the 0 0, if you apply the 1, that time the next state value change as a value of the 1 0, and this is the 1 1 will be the output. That this total discussion already done for the previous few classes, though it is repeated in here, which is required for representing the convolution code diagram. So this is the state table, and the same thing is applied for the case if it is think that the present state value is maintained as a value of 0 1 as initially for the memory unit, and that time you are applying the input as a 0, the present state next state value after the triggering of this, the value is changed as a 0 0 for the next state value, and the output is come as value of 1 1, and for the 1 as the input for the same present state value, the present state next state value will become as a value of 1 0, and that time the output is the 0 0. The same way this total task is done on there. So that means if for the S3 as a present state value, that time if you apply the input of 0, that time the next state value is come as a value of 0 1, and output is coming as a 0 1. If you apply for the same present state value, as you say this is 1 1, that time input is the 1. If you apply the present state value will be changed as the next state value as a 1 1, and the output is the 1 0 on there. So this is the state table for the 212 code, and now we just check that what is the form for the state diagram on there. So look that if you consider for the first state, look that in here when you apply the 0 0 present state, if you apply the input 0, the next state also come back as a value of 0 0, that is it is come back the same position for the state. So in this case look that here if you consider the 0 0 state, and if you apply the 0 as the input, it is come back at the same position. Look that this is come back at the same state position. Here total number of state is considered the 4 because the memory unit is the 2. So for the memory unit the data can be 0 0, can be 1 0, can be 1 1, can be 0 1. So this 4 state is initially written on there, and then for the individual state the input can be 0 or 1. So if you apply the 0, that time here the solid line is applied. So in this case this is the solid line. If you apply the input as a 1, that time it is indicated by the dotted line. So this is the dotted line on there. So from the state table you can check that when the present state value is 0 0 and input is applying the 0, that time the output is the 0 0. Check that here, check that here when the present state value is the 0 0, that time next state it is come back at the same position, and the output value is the 0 0, and that is written in here, that is written in here. Look that the this branch the value is given as a 0 on there. This is the output value, and when we apply the input for the present state value is 0 0, the next state value is changed as a 1 0. So this is changed as a 1 0 due to the reason of you are applying the input 1 on there. So this output is come as a value of 1 1 on there. So if you consider for the case 0 1, for the case 0 1, the next state value will be the 0 0. 0 1 if you apply the input, that time the next state value will be 0 0 for the input of 0, and the output will be 1 1 on there. Check that this one is coming or not. When you are applying the input 1, when you are applying the input 1, that time for the present state is 0 1, that time its value will become as a 1 0, and when you apply the input as a 0, that time the next state value will be the 0 0, and the output is there 1 1. So this is reflect in the state diagram which is explained in here. Look that this one is, that is when you are applying the input 0 for the 0 1 as a present state, it will be 0 0, that is 0 0 initial is 0 position, and the output is the 1 1. And when you apply the 1 as the input for the present state 0 1, that time the next state is the 1 0, the output is 0 0 on there. So this is reflect on here. So this is the total diagram by which you can draw this one. So in here, this is also written to you. Look that in here, for the value, of as I say, if you consider the present state as 1 1, so when you apply the input 1, when you apply the input of 1, that time what happened? This is come back at the same position as a present state, as a value will become as a next state value also same. That is the 1 1 will become on there, but the output will be 1 0 on that case. Check that. When again I just repeat that 1 1 is the present state, it will be come back the same next state when you apply the input 1. So here for the present state is the 1 1. When you apply the 1 input, it is the same, that is the 1 1, and the output is the 1 0 on there. So this is 1 0 is coming on there, this is 1 0 is coming on there as the output. Okay, and when for the present state is 1 1 and you are applying the input 0, at that time the next state value is the 0 1 and output will be 0 1 also. Check that this is coming on not. For the input is 0, for the input 0, that time present state this 1 1 is changed as a 0 1 and the output is 0 1 also. So this is reflecting here also. When the present state is 1 1, that time the next state due to the reason of input 0 is 0 1 and output also 0 1. So this way you can represent this one for the state diagram. Otherwise you can also apply the same as a bold line, but you just specify as a slash one. As I say, in this case, if you consider for the first one condition, let the input is the 0 0 0 0. If you apply the 0 as the input, 0 as the input, so that time you just write down as a 0 slash of 0 0. So here first 0 is indicate this is the input, and this slash 0 0 it is indicate the output 1. And for the input of 1, this will be as the next state value is the 1 0, and you can write down as a 1 slash of 1 1. Look that this is the 1 1 is the output, so it is written as a 1 as the output, and this line is due to the input of 1, so it is written in here as the input of 1. So if you consider for the 1 0 as a present state, for this one, let this one state. So for let if it is the 1 0 as a present state, if you apply the input as a value of 1, if you apply as a value of 1, that time the next state will become as a value of 1 1. Look that this is the 1 1. That time you have to write down this is 1 slash 0 1. Why this is 0 1? Because 0 1 is the output on that time. And if you apply the 0 as a input, look that when it is 0 as input, next state value will be 0 1. So this will be written as a 0 1 0 1, and due to the reason of the input of 0, so this is 0 slash of 1 0. Why this is 1 0? Due to the reason of this one, that is the 1 0 is the output, and 0 is due to the input of this, that is the 0 is the input for this convolution code. So by this way also you can represent state diagram, not required as a dotted line on there, but you have to specify as a slash form. That is in this case, for this case you have to write down here as a form of 1 slash as a double one. Here it will be 1 slash 0 1. Here it will be write down as a 0 slash 1 0. This will be also 1 slash, this will be the 0 slash in this way. So this is total formation can be represented for the state diagram on there. Okay, so now we are interested to identify what will be the encoded form for the input of or message bit of as a form of, let the message bit is represent, u is represent as a value of 1 0 1 1. So what will be the form of this one? So if you apply, as initially we just think that the present state value is the 0 0 on there, okay, 0 0 on there. So when you apply the 1 as the input, so it will become in this position, and that time the output is 1 1, so you just write down the 1 1 on there, okay, for the first one. For this one it will be 1, and now the present state will become as the next state value of 1 0. From this 1 0, here input is applied as a 0. So for the 0 input, the next state value is the 0 1. So what will be the output in this case? This is the 1 0. So it will be the 1 0. And now that time the newly come as a form of the present state will be changed as the value of the next state as a 0 1. So from the 0 1 again the 1 as the input. So for the 1 input, the present state value will become as a 1 0 initially again on this position, and the output value is the 0 0. So you have to write down 0 0 on there. And lastly here the 1 is again input, so 1 is the input. So for the 1 input, what will be, this one is represent the 1 input line, that time the output is the 0 1. So this is the 0 1. So ultimate, this will be represent the code or encoded code for the message of 1011. So the convolution code value will be 1110010001. So this is the easiest way by which you can represent the data for the convolution code. Again taken another example, so it will be easy for understand also. Let we consider the input is specified as a, or message is specified as a value of as a form of the 0 1 0 1. This one is the message. Initially the state value is the 0 0. So for the first 0, the input is 0, so it is come back in this position. That time the newly come the next state value is the 0 0, and the output is the 0 0 on there. So it will be for the 0, the code word is the 0 0 0. Now the 1 is come on there as the input, so next state is come now 0 0, and due to the input of 1, its value will become as there 1 0, and the output is the 1 1, so you just put the value of 1 1. And then next state 1 0, and here from this 1 0 you have to go due to the input of 0. For the input of 0, the next state newly come next state is the 0 1, and output is there 1 0. So you have to write down 1 0 on there, and from this 0 1 you have to go due to the region of 1 input. So for the 1 input, this is the line, and here the output is the 0 0. So this is the total encoded data for the message of 0 1 0 1. So by using the state diagram, you can easily able to identify the encoded convolution code. So this is also very much utensil for identifying the message bit. So I think each and everyone can able to understand what is the way by this state diagram the ultimate encoded code word for the convolution code can be generated. So next day we will talk about the tree diagram, that one also the most important one for representing the convolution code. And hope each and everyone can stay next day also. Have a good day and stay safe.